Hey everyone, welcome back from that last break. We've come a long way today. It's been quite a day full of amazing content, but we've all made it to our closing talk. So I would like to welcome J. Paul Reed, who will be giving us insight about resilience engineering and what it means particularly to our current circumstances. Welcome, J. Paul.
Awesome. Thank you for that. We all good? Okay. So first of all, I wanted to give a shout out, thanks to Jason, Kimber, Carly, Tim, Allie, Flora, and the rest of the crew. I know this is a unique situation for all of us, and this is an interesting example of adaptation. So a lot of people think online conferences are easier. They're not. They're hard in different ways. So shout out to the crew there. This is a unique situation for all of us, but there's some bright sides to it. I want to give a shout out to my mom who's actually watching this. She doesn't often get to go to tech conferences and see me speak. So that's fun. Hi, Mom. So the agenda for the talk today, there's recently been a lot of interest in resilience engineering in our industry. I saw a tweet, resilience engineering is the new DevOps. So in some ways, it's taken almost this kind of glow of a halo among certain camps kind of in our SRE and tech and DevOps circles. And I know it's been a long day full of some really, really great talks to kind of get us through our quarantine and talk about all of these concepts. So I just want to take a few minutes and talk a little bit about resilience and resilience engineering, a couple of concepts, and then some thoughts that hopefully will be useful for you and your teams as we navigate this sort of new world that we find ourselves in. I'm going to do Q&A at the end, and so I'll stick around for that, and hopefully there'll be some good questions to answer. All right, so I hate putting up this slide, especially as the second slide in the deck. So I'm not going to read it to you except for two things. I'm at J. Paul Reed, just my name on Twitter. So if I say something interesting or you have a question there that you want to point out or something, feel free to tweet me there. The other thing I wanted to point out is this picture. We're all doing things in this pandemic to cope. So early on, I decided, you know what, let's just not shave and see what happens there. So I'm going to keep it until the pandemic or the quarantine is lifted, and we'll see what happens there. But since I can't look out into the audience and connect with you, one of the things I wanted to ask is I would love to hear what you all are doing to cope. So if you want to tweet at me with the hashtag Failover Conf with what you're doing, I know a lot of people have taken up baking. I wanted to mention, speaking of my mom, one of the things she's been doing is whenever she sees somebody on Facebook that can't stream a show on Netflix, she now texts me and asks if Netflix is down. So that's her quarantine thing that she's been doing and helping with Netflix's reliability, and we appreciate it. All right, so I wanted to start a little bit with resilience engineering. What it is, some of you may have heard this term before, some of you may not have heard this term before, so that's a good place to start. And one of the things that I thought was interesting about this book, which is quite an old book on resilience engineering written by some of the big names in the field, is that it has pictures of the industries that we normally think of when we think of when we discuss resilience and robustness and reliability. So you see space travel and aviation and nuclear power and things like that in there. But for a lot of people, it's still kind of confusing. In some sense, we sometimes might do resilience engineering a little bit of a disservice. I laughed at when we try to explain it. I laughed at this cover because this is the follow-up cover to the same book, and I find myself wondering, like what is that? Is there's like a person standing there with waves of resilience falling over them or something? Like it doesn't make a ton of sense. And so hopefully we're going to make a little bit of sense of it today. It doesn't help that there are a lot of R words around this topic: robustness, reliability, resilience, rebound, resiliency. A lot of times we use these terms interchangeably, and it turns out that can muddle the waters a little bit. And so hopefully we're going to try to clarify a little bit of that today. By the way, I wanted to point out, if you use resiliency, I frown on that word. It's funny, if you Google resiliency, the first thing it will ask you is, did you mean resilience? And then if you link to a page, there's a page in there that is resilience versus resiliency. And the favorite quote from it is, usage authorities consider resiliency to be a needless variant. We'll talk a little more about that later, but I prefer resilience over resiliency, but maybe that's a thing of me. All right, so to clarify some of these kind of foundational concepts, I want to use an example of an intersection. And this was an example that Alex Ellman, he's _pkill at _pkill on Twitter, and he's an SRE at Indeed, mentioned. And I thought it was a really, really good example. So I want to walk through it because it kind of will ground us in the discussion, which I think is really useful. So the first one that we talk about a lot is this idea of robustness. Now, if you look at the specific definition in the very hoity-toity academic literature, System X, it defines robustness as System X has property Y that is robust in sense Z to perturbation W. That's a lot of big words. But so in the traffic intersection example, a good example of robustness might be incandescent bulbs in a stoplight versus LED bulbs, right? LED bulbs last longer, they're brighter. They you know, if something hits the lens, they break less, or if one of them breaks, it doesn't take the entire light out. And so in that regard, they are we would call them robust when we talk about sort of resilience engineering. If in software, a similar concept might be using languages that have memory safety guarantees. So like Rust or Java instead of C or C++, you're not going to over-index an array. Those other languages are robust in the memory safety or memory guarantee case. So the key point about this is that disturbances are really well modeled. And the part that we're solving for, we understand, and we're actually solving for a specific situation in that is going to be jarred in a specific sort of way. Let's talk a little bit about reliability. So these are more patterns that support consistent operation or service levels. So in traffic lights, you see reliability here in that there are multiple lights. So that if one of those lights, goes down, either the green light or all of the ones in the particular stoplight, there's still other ways that we can get that information and maintain that service level. Those lights, it's important that they're all synced together and showing the same light. So that's a reliability pattern that we would design for. So in software, you might think of cloud, or maybe more accurately operating in multiple cloud regions as a way of reliability. Another interesting one is like a web browser. If you develop a web browser on a bunch of different platforms, you might find issues that might only show up for instance, in Linux, but there's still actually a bug. They're undefined behavior on Windows as well, but it doesn't actually crash, but it might crash on Linux and vice versa. So there's reliability there a little bit in the code. So the key point here is disturbances are well modeled, but the properties are more patterns and practices. Let's talk a little bit about rebound. This is a really interesting example. It's defined as the ability to deal with a crisis situation dependent on the structures that have been developed before chaos arrives. And the really interesting example for an intersection is, so if you have intersection lines, and we can see in that first example, we've got crosswalks and places for the bikes to go, and there's lanes, there's even a turning lane in there, right? That is very different than an intersection that might not have those lines. And so when those systems are stretched, and I'm thinking there's a great picture, well, not a great picture, but a very interesting picture of the California wildfires, where there are roads like this that don't have that sort of built-in infrastructure sort of around them. And so when the system stretched, they couldn't rebound in any sort of meaningful way. Whereas if there's an accident or heavy traffic, there's some guidance built into the system from previous experience that can be tapped into to allow the system to sort of rebound. So in a software context, we might talk about a CI/CD pipeline. The interesting one there being that when you have an emergency deployment that you need to do, you can go ahead and use the CI/CD pipeline and know that you're going to get all the steps that you need to get done and have a successful deployment, as opposed to trying to roll your own in addition to there being this emergency that you're sort of trying to deal with. So you can get get the system to rebound quicker. So key point here, property rebound is inherent to the system before the chaos happens, often informed actually by previous experience with chaos. And finally, we come to the R we're talking about, resilience. And the tweet that Alex was referring to had mentioned this was during the power outage in, I think, late 2018, or maybe it was early 2019 in New York. The power was out for some amount of time. And there's a video in the tweet of this gentleman stepping into the intersection and for the last 45 minutes, keeping this intersection alive, directing traffic, directing people, allowing cross traffic to cross so that there wasn't too much backup on the side streets. And what I really liked about Alex's tweet is the way that he captured all of this together. Those arrays in instead of bulbs are this robustness, but this New Yorker, this person is an example of resilience. And I thought he just summed that up really beautifully. There's a quote in resilience that we use a lot of times saying resilience isn't something you have, it's something you do. I originally in a tweet thread attributed this quote to Dr. David Woods. It turns out I was poking around to make sure that was accurate, and it turns out actually a lot of the resilience engineering luminaries, Eric Holnagel and Richard Cook, have said similar things. Another expression of this is resilience is a verb. Right. Again, this idea that we're doing something, which, by the way, is I don't like. One of the reasons I don't like resiliency, because I am resiliencing, as in I'm doing resilience sounds okay, but we are resiliencying sounds kind of weird. So, yeah. All right. So now that we have a little bit of an idea about kind of resilience and some of the foundational concepts around resilience and resilience engineering, I want to talk a little bit about the situation that's probably front of mind for a lot of us right now. And in many ways, it's the reason that we're actually here, the COVID-19 situation. And so, these are all stories from early March. And of course, the stories have continued to today about various systems, both macro and micro, really shutting down and responding to this once in a century pandemic. So let's talk a little bit through how we might apply some of that, or how resilience engineering is going to be relevant for us in this particular situation. So I want to talk a little bit about adaptive capacity. That's actually one of the other framings of resilience engineering that you find is really important, is the ability of a system to actually stretch and adapt and bring if resilience is a verb, if it's something we do, the idea that you can store the ability to do that up and then use it, right? Have a capacity to deploy it and use it. And so one of the interesting situations that we really saw illustrated, especially in tech, but in a lot of systems, but since we're at a tech conference, we're going to talk a little bit about tech, is how tech companies actually were able to deploy this adaptive capacity, or maybe they weren't able to deploy it. So some of the really interesting questions that you might ask yourself about being a month or so, 6 weeks into the quarantining and the adaptations that we're going to is how unique are these interventions that and adaptations that you're making. And another way of sort of saying that is, are these adaptations being passed along as in all the teams need to do this? Or are teams able to make their own unique, locally rational intervention and adaptations that are good for them and relevant to them? And the more unique they are, that is a sign of more adaptive capacity, or a system that's going to support adaptive capacity in a way that's going to lead to sort of better outcomes. Another measure is how small can they be and still maintain effectiveness? So one of the heuristics here is, do we see big violent swings in sort of like behaviors around adapting to the situation? Or do we see more subtle motion towards a particular state or endpoint, right? As an example, right, working remotely was a big deal for some organizations and companies that had sort of said, hey, we're not going to do remote ever. And this was less of a disturbance, less of an impact for companies that even had weren't remote first, but even had a few remote employees. They were able to sort of deal with that. It's interesting for me. because I'd been a consultant for so long, I already had a home office set up with a standing desk and an office chair and all of that. So it was working from home was not a big deal. I know some of my coworkers didn't have that set up, and that it was initially difficult for them to sort of navigate that situation. So this can actually be personal adaptations and also team adaptations. How quickly can we modify them? So there was a great tweet that I saw the other day that was like, our digital transformation was completed by A, the CEO, B, the CTO, or C, COVID-19, right? So how quickly were we able to adapt, and how were the structures in place to allow us to quickly make those changes? Or for instance, to maybe get an office chair, did we have to go through 48 pages of expense reports to get it approved and shipped out to you, as an example of what we were talking about previously? So those sorts of questions. And finally, signaling mechanisms, right? So are there appropriate signaling mechanisms in place for us to actually understand those adaptations, the effect that they're having, know when we can ease up on them or maybe lean into them? There's and without a signaling mechanism, they can actually be quite problematic. There's a great quote: organizations can undermine, inadvertently, mind you, their own sources of resilience as they miss how people step into the breach to make up for adaptive shortfalls. So the point being that sometimes organizations, when they don't actually have that signaling mechanism and they can't see how people are actually adapting locally, they can hinder their own whole adaptiveness and adaptive capacity. So the real question, and this is kind of an interesting one for all of us, is organizations that are able to have adaptive capacity, the real goal is to maintain it, right? Because we've all been able to drum it up in some form or fashion as a result of this COVID situation. But really, organizations that this situation was easier to deal with had some adaptive capacity stored up. And they were able to sort of light it up, kind of like dark capacity or like dark fiber in the ground. They're able to light it up and make use of that. And so that is really one of the interesting aspects of this when you look at organizations that have faster pace of change, and you can actually see it in deployment pipelines. And when we talk about DevOps and being able to deploy faster, one of the tenets of that is supporting change quickly. And so that was an interesting proxy for organizations that are really good at constant deployments, leaning into that, fixing the issues when a deployment happens. That is, in a sense, a good heuristic for how much adaptive capacity they might have in a situation like this, because they're able to react to the change of deployments and code, but they're also able to react to external changes as well. One of the other things I'll mention, there's an interesting lean connection here, right? If you listen to NPR, there's a lot of talk about supply chains of large supermarkets versus supply chains of more local markets and the differences between the two, and how the larger changes sort of optimized all of the waste out using lean. It's interesting to consider that Agile is just based on lean, and we've been pushing to mimic the big supply chains that are actually now having certain problems that the smaller supply chains that are a little more adaptive in the way that they can pull on different supply chains, and they're not as optimized as the big chains, what they're seeing. So that's kind of an interesting thing to think about. So this raises an interesting question. This came up on Twitter. During this once-in-a-century global pandemic, do you stop deploying? You might ask yourself, did we put a code freeze in place? The discussion on Twitter was a lot of organizations were actually doing that, and that brought up sort of, no, that's a stupid idea, or it's a stupid that you think it's a stupid idea. So, it was a standard sort of Twitter debate. So one of the things I want to point out about this, a lot of times we talk about the blunt end of the system and the sharp end of the system in it when we talk about socio-technical systems. Sharp end being people at the front lines doing the work, doing the coding, running the systems, doing the deployments, all of that kind of stuff. The blunt end being people that are further away from the work, higher up in the organization. Often when we talk about, faceless managers, the reason we know managers, but the reason they're faceless is they're part of that blunter end of the system. And so the point that I want to make here is that it's really interesting that I think, should we deploy or not? Should we do a code freeze because of COVID? Is actually the wrong question. It's the wrong question to ask. The question you really want to be asking is, where is the idea to stop deploying coming from? and where, if any, is pressure being applied to support that idea. And so the thing that I sort of pointed out in that discussion is, if you've got the change board, a change advisory board saying across a huge organization, no changes for anything because of COVID, that's a very different statement than a team saying, you know what, for our local situation, because of how COVID has affected our team, we're going to signal up that we don't want to do deployments for some amount of time, and we're going to explain why. And so that really, these are actually more relevant questions when you talk about adaptations, such as, do we continue deployments? Do we do a code freeze? Rather than whether or not we do the code freeze. You want to ask where these ideas and where these adaptations are actually being actually coming from. So what now? What are we going to talk about now? Well, there's a couple of concepts that are really critical to resilience engineering that I want to talk through that are actually very specific to COVID-19. And as we walk through them, I want you to kind of think potentially about how this has expressed itself within your organization, within your teams, potentially within other team units like your family, whether that be immediate or extended, and see maybe what these concepts from resilience engineering can tell us about how we might cope better with this situation. So one of the things that you find when they talk about coping with cognitive load, and I think we've all talked about being stressed out. I know I've at points have had trouble sleeping because I'm thinking about so many things recently. There are different strategies that have been identified to deal with cognitive load. So what's interesting to me about this is that these are often considered in the context of like slow tempo versus high tempo. So in other words, incident versus not incident. But the issue here is that it's an external pacing. So in other words, something is forcing us to have more cognitive load. And I think we can all agree that COVID-19 is one of those. So one of the trade-offs is to shed load. In other words, do less. One of the interesting things about this is the risk here is you might shed the wrong task. So it takes some heuristics to make sure that you shed the right task, or maybe you adapt enough. You can adapt quickly enough that if you do shed the wrong task, you can actually pick it back up again before something bad happens. One of the other things you can do is trade off thoroughness in each task. So this is, you continue doing all of your tasks, but you do them less thoroughly than you normally would. One of the things that I would point out is whether or not we're conscious of it, I would suspect that we are all doing this right now. And whether or not we're choosing to or not, it's just something I think that we're trying to do as much as we can, but we probably aren't doing everything as thoroughly as we would normally do it in whatever context that we're talking about. You can shift work and time. So I see this a lot actually with parents who have families, who have kids. They're maybe working earlier in the morning or later in the evening. And this actually has interesting impacts to on-call and when changes get deployed. If we're used to more changes occurring during the daytime, during the work or hours. But this is one strategy to deal with that, is we shift work to different periods in time. And then the last one, recruiting more resources. This may actually be especially difficult right now, and I'll talk about that a little bit here. One of the points I want to make before we go on is that the first two are tactical in nature. They're things that we do kind of in the moment, and as I said earlier, sometimes we don't even consciously think like I'm going to do this code review a little less thoroughly than I already would because I'm worried about my family and the schooling or whatever it might be in this particular situation, right? But these are tactical strategies. The other two are more strategic strategies. And the reason that's relevant is the two strategic strategies, shifting work and time and recruiting more resources, you can plan for them. The reason they're strategic is you can see, I can plan to do this work later, but there is often an organizational impact in those changes, especially in recruiting more resources. If you ask for help, that's going to impact the larger organizational system in a way that the first two, because they're tactical, are more likely to generally impact you. And they're a lever that you can pull sort of yourself without sort of the overhead of a lot of extra coordination. So the key point is you're probably doing a lot of these already, but understanding the difference between the strategic coping mechanisms and the tactical ones is useful because the impact is different, and you would want to look for the impact in different ways depending on which one you're deploying. The second concept, or the last one that's relevant to resilience engineering I want to talk about, is this idea of common ground. And I could read you the literature, the academic literature, resilience engineering definition of it. I'm not going to, because we all have a sense of what it looks like. If we've ever seen a team where you watch back, sit back and watch them work, you can see it with sports teams, you can see it with firefighting crews, you can see it with SRE and ops teams, DevOps teams, referring to or dealing with a particular incident. So you've probably seen that where certain teams are just better at doing the task at hand as a group than other teams. That is an example of sort of a strong common ground. So the aspects of this that you should think about and that are probably impacted right now is this idea of sort of a basic compact. So that's the idea that we're working together on a shared project, shared goal. And one of the really interesting points is part of the basic compact is when you need to announce that you're leaving the compact, right? If you're saying, I'm no longer participating in this goal, we're going to come back to that because it's important. Alignment. So we all have multiple goals. So what are the goals? What are the important ones? What are the more important ones? What aren't the less important ones? What aren't the goals? Are we aligned on our roughly aligned enough to participate and have common ground around it? Interpredictability is really important. And I want to read the definition here because it's really useful. So it's the ability to predict the actions of another party with a reasonable degree of certainty. But here's the other really important part. It's also the ability to act ourselves sufficiently predictable to see things from other points of view. So this is part of that basic compact that we enter into when we have common ground. So society is rife with it. I'll give you a great example. If I were to go into Starbucks and I go up to the cashier and I say, hey, I'd like a cup of coffee, and they shout at me, the zebra is blue, and then push all of the things off the cash register and then run away, we don't have common ground. That common ground has been broken because there were certain expectations I had, and they were probably expecting certain things out of me, right? So there's a societal version of it, but the quintessential trope, actually, where you see it with teams, if you've ever seen two people and they're like, yeah, so I was talking to so-and-so and they said, and the other person cuts them off and says, yeah, I knew they were going to say that. And then they say, well, so I don't know how to do that. Do you think, and they go back and forth and they don't even finish the sentence. They don't finish each other's sentences. They have a conversation in fragments. And that's an example of two actors that have incredibly good common ground. Now, the last part of it that's really important is sustaining and repairing common ground. So this is the idea, you did something I didn't expect. How do we fix that? There's a couple of ways we can fix it. One is in the moment. So if you do something and you're and we have the tempo of the situation is slow enough that we're able to say, hey, what happened? Then we can repair it right there. A lot of us in an ops context do it as part of a retrospective. You did something I didn't expect. Let's figure that out together. Another one is, how do we tell if we've fallen out of alignment of our goals, right? How do we go about repairing it? How do we fix that expectation that was broken? Do we fix it, right? So the key point here is that teams that have weak common ground to start with before COVID are probably going to be really struggling right now, because interpredictability is highly impacted, and the signals that we get normally to know we need to repair that are highly impacted. So the suggestion here is focus on the sustaining and repairing. Don't try to develop common ground, but lean into trying to maintain the interpredictability you have. And also remember how I said dropping out of the compact is really important. If you have to take care of your family, letting people know, like, I'm actually not available, I'm not around, is super important to common ground. If you're actually not present, even though you're on Slack, it's important to let people know you probably shouldn't rely on me today. All right, so a couple of last thoughts. These are some tweets. I love that Corey Quinn noted that I'm a real victim in the pandemic because I can't talk about airplane disasters. In fact, airplanes aren't really flying a lot right now. So what I want to do is, there's a video. It's about a minute long. And it took place during the quarantine. So if we can switch to the video. And I want, and we can go ahead and start it too. I want you all to watch this video. And what I want you to see as this video progresses, I want you to see what you notice. Observe what you notice about this particular video. What are your thoughts and feelings about it? So those that know me know that I couldn't do a talk without an airplane reference. I know Rich Burrows said that I was going to say something that was going to scare the hell out of him. Hopefully that didn't, because this had a very good outcome. But I want to ask a couple things if you notice this. This situation started out pretty normal. If you watch the video from the beginning, did you recognize the point at which you personally went, oh, this is not normal. This should not be happening. That's one thing to really notice. And that's useful when we talk about these situation changes that are weird and unexpected. The second one, did you notice that a bunch of cars turn their hazard lights on? You might ask yourself, would autonomous cars do that? Would they know to do that? How did the people know to do that? Finally, there wasn't any blunt end organization function here. The highway patrol wasn't immediately out there saying, all right, everybody slow your cars down and let's form up a line around the plant. None of that happened, right? The system of drivers were able to still adapt to that without that sort of overall forcing function, which I think is pretty interesting. So as we go back to looking at this broader COVID situation, I just want to remind all of you that, like in that video, it's the people that are going to bring their unique adaptive capacities to bear on this problem. Automation isn't going to get us through this. Mandates from the executive building to deploy more safely aren't going to get us through this. It's you, it's me, it's us, resiliency in our way through it together. Stay safe, stay healthy, and stay resilient.